Nowadays, thanks to the help of machines and advanced technologies, using many different methods, we have been able to build modern bridges in a very short time. Each bridge has an extremely unique construction method depending on the terrain, design requirements, as well as the structure. China is one of the countries with the world's leading modern road and bridge system. The technical magicians in this country once surprised the world by building the Chajiaotan Suspension Bridge in Guizhou Province, one of the tallest bridges in the world, or the longest sea crossing bridge in the world that makes us admire. How did China build such incredible bridges? What methods are China using to accomplish these utopian projects? Don't move away from the screen. Let's dive in to find out in today's video. But before that, I would like you to show your support by liking videos and subscribing to channels. We are grateful and appreciate what you have done to make Top Wonders grow more and more. Geological hazard mitigation products and slope protection measures are critical components in infrastructure development and safety in areas prone to natural hazards such as landslides, falling rock, and soil erosion. These products and measures are designed to minimize the risk of natural disasters, risks associated with geotechnical instability, and provide long-term stability to pitched roofs and embankments. It covers a wide range of geosynthetic materials and systems specifically designed to reinforce and stabilize slopes. These include geotextiles, high-strength wire mesh, geotextiles, and erosion-resistant blankets. These materials are selected based on durability and compatibility with site conditions to prevent slope damage and erosion. The manufacturing process of geological hazard minimizing products includes the selection of high-quality raw materials such as high-strength steel wire and the use of advanced manufacturing techniques. Rigorous testing is conducted to ensure products meet international standards for durability and performance. These engineering marvel bridges symbolize humanity's ability to overcome geographical barriers and connect communities. These feats were the backbone of the construction of the Arch Bridge, with the longest thrust span in the world, an example of engineering excellence. This section delves into the intricate process of building such a bridge, while also exploring notable advances in steel tubular arch bridges stuffed with concrete. Materials are the basis of bridge engineering. Therefore, the development of longer bridges is based on the development of material technology. So far, domestic China has met the output of concrete, steel, cable, composite materials, and smart materials. Some of these materials represent world-leading technologies. C50 and C60 concrete are widely used in China. Fiber, lightweight, and ultra-high performance concrete has also been researched and is gradually being applied. The improvement of the performance of concrete materials in order to improve their structural features has received a lot of attention. The development of steel in China has gone through stages of low carbon, low alloy, high strength, and high performance. Currently, Q345 and Q370 steel are widely used, while Q420 is gradually being applied. Q500 steel has been successfully developed and applied for Shanghai Nantong Yangtze River Bridge and other projects. 700 MPa grade steel is currently under development, and epoxy-coated steel bars and stainless steel bars are gradually being adopted. In terms of cable material, 1,770 megapascal steel wire and 1,860 megapascal steel fiber have been localized and applied in engineering. 2,000 megapascal steel wire, a zinc-aluminum alloy, has also been successfully developed and applied. Composite materials, such as fiber-reinforced plastic, FRP, have been applied in bridge repair and reinforcement, and corresponding application research on cables has also been carried out. New smart materials such as shape memory alloys, piezoelectric materials, optical fibers, and smart self-repair concrete have gradually been researched and applied in bridge monitoring and reinforcement techniques. This combination of materials will create a composite structure capable of withstanding various environmental factors, including seismic activity, soil settlement, and dynamic loads. Decks in particular need to be firmly reinforced to support constant traffic loads, and the environmental stresses they endure are placed in concrete floors to enhance load capacity, prevent cracking and corrosion due to exposure to extreme weather conditions. In addition, the flexibility of the reinforcement allows the engineer to design the bridge deck with longer spans, reducing the need for additional support structures and optimizing the overall efficiency of the bridge design. The work of reinforcing the structure facilitates the construction process by providing formwork support that ensures dimensional accuracy during the pouring of concrete. By properly positioning and fixing the reinforcement, formwork can create a framework for pouring concrete in accordance with the desired shape and specifications. This accuracy is essential to achieve uniformity and consistency in the finished structure, minimize the risk of errors, and ensure compliance with regulatory standards. Moreover, the reinforcement provides design flexibility that allows engineers to adjust the reinforced layout. Important structural elements of a bridge, such as bridge towers, main beams, cables, arch ribs, and foundations, are constantly being developed and renewed. The design technologies of structures such as concrete bridge towers, and steel concrete composite bridge towers over 300 meters have been learned. New anchor structures such as integrated steel anchor boxes and planned ring cables have been launched. Chinese engineers have achieved innovations and breakthroughs in the structural forms of main beams. Split steel box beams have been successfully applied to residential suspension bridges for the first time. 3-truss steel girders are being developed. Moreover, design technologies for steel concrete composite beams and hybrid beams are becoming more mature. The durability, longevity, and intelligence of cabling and anchoring systems have been steadily improved, with the development of a durable parallel cable-stayed system with a design service life of 50 years, a force distribution anchoring system, and a real-time monitoring non-linkable pre-stress anchoring system for the main cable of the suspension bridge. Concrete arch ribs, steel box arch ribs, steel truss arch ribs, steel pipes, and rigid skeleton composite arch ribs are widely used and have led to the achievement of world records for spans of various types of arch bridges. For substructures, key design technologies for new types of foundations have been developed, including super-large, irregularly shaped group pile foundations and variable dumbbell-shaped cross-sections, super-large diameter board pile foundations, concrete caisson foundations, large steel, enclosure of large circular continuous wall anchor foundations underground, caisson synthetic foundations and pipe columns, and infinity-type underground fin wall foundations. China owns the technology of building and controlling various types of bridges under different construction conditions. The industrial construction technology is developing rapidly with continuous improvement in the level of automation, production efficiency, and stable quality. The majority of the main construction equipment used in bridge construction is manufactured in China. The level of automation and the ability to manufacture equipment is also significantly improved. About technology and equipment for construction of ultra-high bridge towers, including hydraulic climbing formwork technology for concrete bridge towers, ultra-high pressure concrete pumping technology, technology for construction of pre-engineered buildings and hoists, and high-precision assembly for steel bridge tower. In terms of the technology and construction equipment of the main beam, the development steps include digitized steel box beam production line, technology of casting and pre-erection of monolithic concrete beams, transportation and erection of beams on built beams, prefabricated and assembled construction technology according to the method of short splicing, construction technology for lifting an entire steel box beam, technology of construction and erection of main beams using cable cranes, bridge deck crane, and sliding formwork and ascending ejection. The precast arch bridge system represents a marvel of modern engineering that combines durability, efficiency, and aesthetics in the field of bridge construction, developed by a leading manufacturer of precast concrete. This innovative system offers a flexible solution to overcome various distances with luxury and structural integrity at its core. For the erection of structural elements, the integrated dynamics of precast pile foundations have been achieved, pre-assembly of the cover and body of the pillar, and the lifting of the whole precast steel bridge tower. For the main beam, large-scale precast and erection technology has been implemented for all operations, including the prefabrication and assembly of small sections of concrete box beams, precast and lifting of large sections of truss beams, super large integrated erection of steel box girders, crossing waterways, and machine erection of precast concrete main beams bridging. Automatic erection has been applied from the upper structure to the substructure. Furthermore, technology that promotes the rapid repair and replacement of large bridge sections has been developed to upgrade older bridges in order to minimize the obstruction of construction to heavy traffic. The system is highly customizable, suitable for different span shapes and load capacities, making it suitable for a wide range of applications from pedestrian bridges to vehicular overpasses and arch bridges. Prefabricated arch bridge systems ensure uniformity and reliability in their operation, minimizing the risk of errors or failures. In fact, prefabricated systems have a number of advantages and disadvantages over other methods of bridge construction. The arch bridge actually distributes the load efficiently, providing excellent structural stability and resilience to various environmental factors, such as seismic activity and temperature fluctuations. The arch structure is inherently resistant to compression, reducing the need for additional support structures and enhancing overall durability. The graceful curvature of the arch bridge actually adds exceptional visual appeal to enhance the landscape for the built environment and create iconic landmarks. Bridges often serve as focal points in urban and rural environments, contributing to the cultural and historical identity of the area. Bridge components on the periphery allow for faster assembly at the construction site, reducing construction time and minimizing disruption to surrounding areas. It is 4 decades since China's reform and opening up, which is a golden era for the development of bridge construction in China. Following the general law of technological development and the path of integration development innovation, China's bridge engineering has gone through 3 stages: learn and follow in the 1980s, follow and improve in the 1990s, innovate and get ahead since the beginning of the 21st century. The development of bridge engineering in China has now taken a significant leap forward with the construction of many extra-large bridges adopting novel structures, difficult designs, and construction, complex high-tech materials and processes. Think about the impressive advances in China's bridge construction technology. Please share with us in the comment section below. Don't forget to like the video and subscribe to the channel to support today's journey. Goodbye and see you again in